Всем привет, how is everyone doing? My name is Alvin. Today we're going to be talking about histograms and video scopes. Now these are considered to be essentials that every photographer and filmmaker should know when creating content. Now what are these video scopes and histograms? These are basically graphs that represent information about every single pixel that make up an image or a video. And this data represents either luminance or luma, which represents the brightness of every single pixel, chrominance or chroma, that represents the hue or the color of every single pixel, and then saturation, which represents how much actual color is in every single pixel. Now why do we need these graphs? Basically, there are two main reasons. The first one, let me actually demonstrate it for you. See these two pictures right here? Clearly the shades of gray are different, right? Now what if I take away the backgrounds? It's the same color now. This is a very famous optical illusion where the same shade of gray is perceived differently by our eyes depending on the background that it interacts with. And when it comes to color, our eyes become very accustomed to and they get used to the color that we look at the more we look at it. And we even, I think, see the opposites of that color. I'm not really sure. But the idea is that you know how you're sitting down, you're editing a photo, everything seems to be really nice, and then you take a 5-minute break, go grab a cup of tea or coffee, come back and you realize it's completely not what you wanted to do. And it looks just bad. Sometimes it looks really bad. So you have to completely do everything from scratch. And that's the point. We cannot really trust our eyes. And the second reason is the monitor or the screen that you are actually editing on, because every manufacturer does them differently. We cannot really trust the screens either. So we need some kind of concrete information that we can always base ourselves on. What these graphs are is math. And no matter on which screen you're going to be looking at, you will always be sure that your footage is at its best because on paper it says so. So let us look at the first one, which is the histogram. So a histogram basically shows us the luminance of all your pixels within your image. And even though it can be found in both photography and in filmmaking, like the editing softwares, it's still used mostly in photography and editing photos. So you can find it in both your camera and also your editing software. In cameras, at minimum, you'll find the histogram when you are reviewing your captured images, given that you have a screen at the back of your camera. If you have a camera such as a Canon, then you can also have live preview, where while you're, let's say, aiming your camera at an object, you can also see the histogram and how it changes, so you can make better decisions. And of course, once you're exporting the photos to your editing software, for sure you'll find it there. Now the purpose of a histogram is to basically show you the exposure of your photo. If we are talking about making a photo on location, it can help you to properly expose your photo. And if you're editing in post, it will help you to properly edit your photo so that we can maximize the dynamic range of your photo. By dynamic range, I mean that your photo will have every single tone of your luminance, at least a little bit, so from pure black to pure white. And actually some people say that having pure white and pure black is bad, but having a little bit of it, I think, should be fine and usually is always okay. Now the way we look at this graph is that on the bottom we have our luminance, so it goes from 0 to 255, which is our pure white, and on the top we have our pixel count. So how many pixels occupy a specific amount of light. Now if you're like me and you're wondering, why is white 255? Well, I did a little bit of research and I will try to explain this one as simple and quick as possible. In computers, data is stored using a system called binary. This binary looks like a bunch of zeros and ones. Basically, every single digit, known as a binary digit or a bit, can be either a on or off, or plus or minus, or 0 and 1. So it turns out that every color channel, red, green and blue, has 8 digits or 8 bits. And these bits can, once again, be either on or off, or 0 and 1s. So our pure black is all zeros and our pure white is all 1s. But that still doesn't explain why do we have 255. So let's take our pure black and pure white with its own 8 digits. We know that every single digit in this system can either be a 0 or a 1. So the question is, between all zeros and all ones, how many possibilities do we have? And every single possibility relates to a level of brightness. So if we take our pure black and we take the first digit, and we know that it can be either 0 or 1, so that's 2 possibilities. Now add the second digit and now we have 4 possibilities, or 2 to the power of 2. Now if you go along the digits, at the end you have 2 to the power of 8. And 2 to the power of 8 is 256. So 256 possibilities of brightness. Now if we have our pure black at 0, 256 will be actually 255, which is our pure white. I hope that makes sense. Going back to our histograms, the 2 main important things that you need to remember when you're looking at a histogram is A, it purely shows what the camera lens sees when it comes to the brightness. And second of all, there is no correct or right way how a histogram should look like. It really depends on A, the setting, and the most important, the intention of the photographer. Let me explain this one on examples. The first image we're going to be looking at is this nice picture of a road in the forest. If we look at our histogram, what does it tell us? Immediately what catches our eye is this density of pixels within our shadows. If you remember, on our vertical axis, it tells us how many pixels we have in a specific area. So in this case, we know that, okay, this image has majority of its pixels in the darker areas, which is, of course, logical considering that we have a lot of greenery, quite dark greenery, also these dark spots on the road, the reflections from the trees. And then the remaining, of course, is evenly spread out between the mids and the highlights. Nothing is super bright except for these spikes right here, which I would assume would be these areas right here which are the brightest. Now moving on to our next photo is this close-up of a ball. And as you can see from my histogram, immediately we can see that there is this huge amount of shadows, which represents the background, which is very dark, and also this under part of our ball, which also is very dark. Also, in this case, we have a little bit of a spike in our highlights, which comes from these brighter areas. And then finally, we have this third photo, super bright, and on contrary to the other two, we have a huge spike of pixels within our white areas. However, we also have a spike in the shadows, which represents our camera and our computer. So with all these 3 examples, the question is, which one of them is correct and which one is wrong? Now, in my personal opinion, the answer is none of them are wrong. Because at the end of the day, if the goal of the photographer and his approach towards a specific photo met, then it is correct. As long as, of course, it occupies the whole spectrum of the luminance, so the whole dynamic range. So in this case, I have luminance in the shadows, in the mids, in the highlights, and in the whites. And then if we move to the next one, we also have all our pixels occupying the whole graph. And it is very visible here in this picture right here, that even though we don't have anything clipping within the whites and the blacks, which is a good thing, we have everything else spread within these 3 ranges right here, and this generates a very nice and pleasant photo. This being said, this graph needs to be used as a guidance for you to properly expose your photos and to, most importantly, prevent clipping. Clipping is when you have too much whites going towards your pure white area, or your blacks or your dark areas going to your pure black. And the reason for this is because in both pure white and pure black, there is no information whatsoever. So if you're trying to edit it, it's just gonna go completely to gray. And you want to avoid this because, for instance, if you're shooting the sky, you want to have this nice detail of a cloud, but if it's gonna be overexposed, it's just gonna be just this white blob of just nothing. So it just doesn't work whatsoever. And the final interesting point about histograms is that I read on some sources that apparently the histogram that you see on your camera, on your DSLR, and your editing program, let's say Lightroom, will differ. And this is because the histogram on your camera reads the information from a JPEG file compared to the one that is in your RAW file. I'm not sure how it is when it comes to live preview, but the significance of this one is that, for instance, when you're reviewing your photos on location, you may seem like you are actually crushing your blacks as per the graph, but then when you upload it and you use your raw file, you'll actually find out that you were not crushing your blacks, which is a good thing, and that you can recover information from them. So just a little note to keep when you're using it. Now let's move on to the more video related graphs, which are the video scopes. Now in video there are 3 graphs or scopes that are used to better assess your image and to make adjustments with your exposure and your color. These are the Waveform, the RGB Parade and the Vectorscope. Let's jump into DaVinci and look at each one of them in detail. So here we are in DaVinci Resolve 17. I already prepared a few clips just to help us to understand the concepts, but first, of course, we need to actually pull up the scopes. The way you can do this one is you can go to your color tab, and then usually on your right hand side you might see them. If you don't see it like right now, it's because we are in our keyframes. So to go to our scopes, just press this icon right here, which looks like a graph, and we have our scope. You can change the type of scope you want to view by going to this drop down menu right here, or you can just expand it to have a bigger version of it, and then you can also choose between 1, 2, which does not move. I think it's because I need to make it bigger. Let me see. There you go. 2 or 4 different scopes, which you can then decide what you want to see within each one of them. So let's go back to our edit page. And this is the cool thing, that once you expand it, you can actually move between the pages and still have the scopes open. And let us go and choose the waveform. So what are our waveforms? A waveform is basically a histogram for video. It does the same thing in terms of showing us the luminance of the different parts of our video. Now there are 2 main things that are very important to keep in mind when you're looking at these waveforms. The first one is that a waveform works a little bit differently than a histogram in the sense that it actually reads information from left to right. So from this part to that part. And as you can see in this gradient, we have our pure black, which slowly transitions towards our pure white. And this is reflected in our waveform by a line that starts at our pure black and goes all the way up to our pure white. Now, by the way, don't worry about these numbers. I know that I was talking about the 255 value of pure white, but in this case, in DaVinci, it is all the way up until 1023. Sometimes you might see it as 0 to 100, I think in Premiere Pro. Don't worry, not that important. The point is that this is pure black and this is pure white. And by the way, that makes me remember and realize the fact that our tone curves that we see in Lightroom and in Photoshop has this diagonal line, which now makes sense. So it's basically pure black and pure white. So the second thing that we need to remember is that the waveform does not actually show you the image. And what I mean by this is that if we go to our next image, which is this checkered image, we have our white on top, black on bottom, and then black on top, white on bottom. But if we look at our waveform, we just have one bar going on top and on the bottom. And the reason why is this is because, as mentioned, the vertical is our luminance. So everything that is white will be on the top, everything that is bright is on the bottom. So in this case, we can basically, what we can do is we can just move it around like this, and let's imagine this line goes right through this scope as well. So in this first half, it says, okay, well, I see white, so we're gonna plot a white line, and I see black, so I'm gonna plot a black line here. In this case, it makes sense. In here, it's the same principle. Okay, I see black, so I'm gonna plot black on the bottom, and I see white, so I'm gonna plot it in the white on the top. The problem arises when you are trying to see your waveforms in a more complex videos, and sometimes, at least for me, it gets confusing because what you see on your waveform is not exactly the same thing as on the video. A good example of this is this section from one of my videos. So we can see this really crazy waveform, and as you remember, it reads from left to right. So if we look at this waveform, in the beginning we have this really big spike in our whites,
So the general white comes from the walls, and then this spike over here I would assume comes from the sun that is casting itself on the wall. Then on the bottom we have our black computer, so we can see here, there we go, we have the computer. Now then slowly it dips, and I would assume it dips because it becomes a bit darker as it goes to the corner. Then we have this really crazy mid-tones all the way here and a bit of highlights. I would assume this would be me, I guess. Now here we have a little spike over here and over here. Now which one would be the microphone and which one would be the hat? Now honestly I don't have any clue because both of them are very bright compared to everything else. So I cannot really judge, but I would assume that maybe the microphone would be, because there's this little section right here which is really bright, so maybe that would be over here. And then moving along we have this long line over here which might be this ladder, and then again a spike of color over here which is the wall. Now here in the middle we missed is this darker part. You can really see it's highlighted. This is definitely my shirt. But again, this is the guessing game. Everything is an assumption. Now the cool part is that when you actually play a video, you can see the waveform change, and that can help you to identify some items. So for instance, playing this video, you can see that my head is here. So in the end I was right, this is actually my hat. It has to be my hat. Going back to this video. Now, a cool feature, at least in DaVinci, I don't know if it is in the different programs as well, is that you can actually colorize this waveform. So if I put it in color, this changes everything. This makes it so much easier, because now I know that the reds is these presents right here. The browns is definitely me, with this lower browns is definitely my arm and the table. And then the greens are of course the tree right here. It makes it much easier to read. But if you're looking at the waveform without any color, it can become confusing. But nevertheless, it's a very handy way to control your exposure, and especially if you have a monitor that you can keep with you on location when you're filming, that can really serve. It's like a histogram for your DSLR. It can really serve a really good purpose. Now let's move on to our next one, which is a RGB Parade, or in this case it's called a Parade. What this is basically a waveform, but now split into 3 sections per each color. So red, green and blue. Each section reads your video exactly the same way from left to right. And as you can see, because it's reading the same video, the waves are quite similar in this case. So why do we need this Parade? Well, this Parade is a very handy tool when you want to white balance your footage. I know there's a bunch of different tools that you can use, but this is also a very good way that does not lie, that allow us to grade our footage. So the way it works, if you remember my explanation about the 255 value of white, the way it works is that when you have your pure black, for instance, you have all your channels has to be at zeros. And if you have pure white, then all of them have to be at ones. And all the 3 channels has to be equal, the same values. So in this case, what we can do is we can compare each channel and see if they are more or less equal. So in this case, for instance, everything seems quite nice and they're quite equal. And in this case, my whole video seems also quite balanced. Now if I go to my color page, for instance, and I change the hue to, let's say, a bit more red, you can see how my footage becomes redder, and also the scope now changes, and now we have more in the reds. So if you have a footage that you see you have like a little magenta or a purple hue, you can just immediately go to your reds, or you can just check on your Parade to make sure how much you want to adjust it for, and there be more precise. So for instance, right now it's a little bit too green, you can see, because the green is popping up. So going it a bit up, and for me personally, I think this is great. Next we have is our Vectorscope. If I go to our Vectorscope, it looks like this circle. Now in DaVinci Resolve, unfortunately, it is just purely black. If you go to, let's say, Adobe Premiere Pro, there it looks a little bit different, and I think a bit better because it has a color overlay. What a Vectorscope is basically a color wheel, exactly like these ones right here. And I think the best way to actually showcase you the Vectorscope is using this color warper. It's basically a color wheel as well, which allows us to color grade our footage, and it represents the same thing as a Vectorscope. And as you can see, if you compare them, you have these greens which are quite saturated, and you can see this line right here in the greens. Then we have this sharp red patch right here, and this is represented over here, quite far away. And then we have our browns, which is my skin, which is in this area right here. So how do we use, or why do we use Vectorscopes? Vectorscopes allow us to, first of all, to control our saturation and our colors in our image. And the rules that apply to the Vectorscope is that the further away we have our lines from the center, the more saturation we have. I can demonstrate this to you by just increasing the saturation, and you can see how the values increase, or the lines increase. Let's go back to 0. This means that if we go back to lower saturation, now we are reducing it all the way down to a small dot in the middle, which is completely monochrome. It's just white and black. Now another reason why you would use Vectorscopes is actually to white balance your images. It is possible, though it's not so straightforward as a RGB Parade. And the way it works is that you want to have your majority of your pixels within the center of your Vectorscope. And this is where you have the more neutral colors. So if I move the whole image towards blue, you can see how everything just moves towards magenta and blue. So you can see this huge trail. It still kind of sticks towards the middle, but anyways, majority of it is just spread around. So the handy thing is that if you see that your video is a little bit offset on one of the colors, you can either see it visually, or you can just go to your Vectorscope and see it. Like I said, it's not very straightforward because, for instance, in this case, you can see that it's quite offset in one direction towards more of the blue and the cyan. However, for me, it looks quite balanced and I like it. Even though if I move everything exactly to the middle, so let's try doing this by maybe adding a bit of red, a bit of green, so like this. You see, it actually does the same thing. It actually looks really good as well, although I can see a little bit of green, but maybe it's just because of my monitor. So actually it looks like this good as well, but in my case, I preferred at the time when I was editing this one, I preferred to have it in a little bit in the blues. And the third, and by far the most popular reason why Vectorscopes are used, is to balance skin tones. It has this really nice feature, I think in any editing software, which is the skin tone indicator. It's basically a line which tells you where most of the skin tones are, so you need to basically keep the skin tone colors or pixels within that line. So it doesn't have to be exactly on that line, but somewhere in that range. So in this case, for instance, my skin tones look pretty good and they are within this line. I'm not a colorist yet, I have not studied this, but this is what I learned from just learning about Vectorscopes. So I cannot really demonstrate you how to correct this properly. For me, just visually it looks nice and I wouldn't really change anything. Maybe I would move it a little bit to the side, but not really a big of a deal. But basically, it's very, very handy for balancing and recoloring your skin tones.
And this is pretty much it when it comes to these reliable tools that are available for us content creators to allow us to better judge and make decisions when it comes to exposure and also color grading and color matching. I hope you found this information useful. I think it is quite a good and interesting introduction towards just color grading in general, both for photos and also videos, something I'm very excited to start with. I hope you found this information useful. Do drop a like, consider subscribing, and I see you in the next one. Пока!